Okay, this chapter here we are going to look at how to use the thermistor and the light dependent resistor in combination with the potential divider circuit to control the variation of voltage. When the temperature in the room changes, we can actually allow this temperature change to change the voltage when you use a thermistor, and when you change the thermistor to a light dependent resistor, you can allow the intensity of the light to change the potential of a circuit at a certain point. Okay, let's see how this can be done. In the example here, example 12, the thermistor, this is a thermistor as shown in this diagram. You must be able to recognize and draw the symbol of a thermistor. It's a resistor with a straight line and a bent line at the end. Now this thermistor is connected in series with a resistor 1.7 kilo ohm, and there is a potential difference of 5 volt between the two ends, 7 minus 2 here. So the PD here is 7 minus 2 volt or equals to 5 volt. Okay. Now when the thermistor is hot, the resistance is 800 ohm, and when it is cold it's 5000 ohm. You're asked to find the potential at point W when the temperature is hot. So if you apply the potential divider equation, okay, at the across, that means between the 2 points W and the 2 volt, right? So the resistance of the thermistor when it's cold is 800. The total resistance is 800 plus 1700. Okay, and then multiply by the total potential difference of 7 minus 2, which is 5 volt, and you get a PD of 1.6 when it is. Now this 1.6 is the potential difference between the lower end of 2 volt and the point W. So the potential at W itself is 2 plus 1.6 or 3.6. Okay, we can repeat the calculation for the case when it is hot to see how when it is hot, the PD across it is actually 5000 divided by 5000 plus 1700 times 5. Okay, if we work out this ratio here, multiply by 5, you get 3.73 volt. And so the potential at W is actually 2 volt plus 3.73 volt, which is 5.73 volt. This is when it is hot. So as you can see, when it is cold, the potential at W is 3.6 volt when it's cold. When it's hot, it is at 5.73 volt. And so as you can see, the voltage here changes from 5.73 to 3.6 volt when the temperature changes from a hot to a low value. So we can connect this point here to some kind of control device and maybe turn on some other device, fan or air conditioner or something like that. Okay, so this is how we can use a thermistor in the potential divider circuit to control another device. Now let's look at a similar example using light dependent resistor now. The light dependent resistor is a kind of semiconductor device whose resistance changes with the intensity of light falling on it. So when strong light falls on it, the resistance drops from a large value to a small value. So when the light dependent resistor is in the darkness, we have a resistance value of 6 mega ohm when it's in the dark, and it drops to 2000 ohm in the light. So we asked to find the potential at point P when it's in the light. So we repeat the same calculation, similar to the one above. So in bright light, the potential difference across the LDR, or the light dependent resistor, is 2000 ohm over the total resistance of 5000 ohm, and this time the total potential difference is 18 minus 3, or 15 volt, and you get a PD of 6 volt. Now this 6 volt is the PD across the LDR, potential difference across the LDR. The potential at P itself is actually 6 volt below 18 volt. Okay, so this 18 minus 6, which is equal to 12 volt. Remember, this is the potential difference is the difference between 2 points. So the potential at P is potential at the top here, 18 minus the potential difference of 6 volt, which gives you 12 volt. Okay, you can repeat the same calculation when the LDR is in the dark. So the PD will be, the potential difference across it will be equal to 6 times 10 to the power 6 divided by 6 times 10 to the power 6 plus 3000, and the whole thing multiplied by 15. Now this is going to be approximately 15 volt. Now without doing the detailed calculation, because the number 3000 is quite small compared to 6 million, so the whole ratio here is approximately equal to 1, or very close to 1. Therefore the PD is approximately 15 volt. It means the potential at P is almost 3 volt. Okay, so when it is in darkness, the potential at P is 3 volt. When you turn on the light, or when a strong light shines on the LDR, the potential increases from 3 volt to 12 volt, and therefore you can connect this point to some kind of device or switch to trigger another switch or another alarm, or some kind of control system can be put in place. Okay, so this two examples are the way LDR and thermistor can be used to control the potential variation in the circuit.